we've learned how to identify what the limiting reagent is, now we'd like to solve a limiting reagent problem. So this question says, if 12 grams of potassium reacts with 25 grams of aluminum nitrate, how much aluminum will be produced? So again, we first need to start with a balanced equation. I've got potassium reacting with aluminum nitrate. Aluminum we know is a 3+ charge, nitrate 1-. So that's my formula for aluminum nitrate. Potassium wasn't diatomic, so it's fine just as K. It says aluminum will be produced, which makes sense because this is a single replacement reaction. Aluminum is not diatomic, so Al. And what's left is potassium nitrate, KNO3. 1+, 1-, so that's written correctly. To balance this, it looks like I've got 3 nitrates on the left and only 1 on the right. So I need to put a 3 on the right. That now gives me 3 potassiums. So if I put 3 on the left, we've got a balanced equation. So the first thing I need to do is figure out what my limiting reagent is. Well, there are 2 ways to do this, and I'm going to do it the way I showed you in the previous video. If I have 12 grams of potassium, I can figure out how many grams of aluminum nitrate I would need to react completely with my 12 grams of potassium. So that's what I'm going to do. I'm going to do a mass-to-mass problem and change the amount of potassium I have into how much aluminum nitrate I should need. First step is always to change what you're given into moles. And the molar mass of potassium is 39.1 grams in 1 mole. Grams cancel out. I've changed it into moles. Second step is the molar ratio. So I can get rid of my moles of potassium by putting them on the bottom and turning that into moles of what I'm looking for, aluminum nitrate. From my balanced equation, it looks like there's 1 aluminum nitrate for every 3 potassiums. My moles of potassium cancel out, and now I can change my moles of aluminum nitrate into grams of aluminum nitrate. And if you remember, in aluminum nitrate, the aluminum weighs 27, and you really have 3 nitrogens. So 3 times 14 is 42, and you have 9 oxygens. Well, 9 times 16 is 144. If you add all these up, we got what? 3, 11, 213 grams in 1 mole of aluminum nitrate. So now we can do the math. Multiply 12 times 213, divided by the 39.1, divided by 3, and you end up with 22 grams of aluminum nitrate. So the question is, what is my limiting reagent? Will I run out of potassium or aluminum nitrate? Well, I have 12 grams of potassium. How much aluminum nitrate do I need to react with all of that? The answer would be 22 grams. So then I just need to identify how much I actually have. Well, the problem says I have 25 grams of aluminum nitrate. I only need 22, so I will not run out of the aluminum nitrate. I've got plenty. That means I must run out of the potassium. So my limiting reagent is potassium. That is the substance I'm going to run out of. Once I know what I'm going to run out of, I will use it to answer the question. So I'm going to take my 12 grams of potassium and turn that into how many grams of aluminum I can actually make. because if I run out of K, the reaction stops. So this simply becomes, once I know the limiting reagent, a simple mass-to-mass stoichiometry problem. 1 mole of K is 39.1 grams. Molar ratio, moles of K for moles of aluminum. From my balanced equation, it's 1 aluminum for every 3 Ks. Those are all canceling out. And then the molar mass of aluminum, 1 mole of aluminum is 27 grams of aluminum. Simply do the math here. 12 divided by 39.1 divided by 3 times 27 would be 2.76 or 2.8 grams of aluminum.